Okay, so in the last video we looked at simplifying square roots with variables. Now we're going to look at higher powers. So first thing, a little note here. Things like cube root of x and cube root of x squared cannot be simplified. Generally speaking, with an exception that we'll address later on, if the exponent on the variable is smaller than the root, we can't really do any kind of simplifying. There's really nothing we can do to simplify it, to rewrite it. There is an exception, and we'll address that exception later on. But generally speaking, if the power on the variable is smaller than the root, then we're done. We can't go any further. So first off, cube root of x. What number would you multiply times itself 3 times to get x cubed? The answer is x. What about x to the 6th? Well, if you took x squared times itself 3 times, you have 2 plus 2 plus 2 is 6. So the cube root of x to the 6th would be x squared. Or as another example, cube root of x to the 21st would be x to the 7th, because 7 plus 7 plus 7, or 7 times 3, is 21. And so you see what we're doing is we're taking, when we do these roots, and we're dividing that exponent 21 by the root 3 in each case. And so if we move up to a higher root, like x to the 4th, well, 4 divided by 4 would be 1, we'd get x to the 1st. Or if we did 4th root of x to the 20th, 20 divided by 4 would be 5. We get x to the 5th. Or if we did 5th root of x to the 15th, we'd get x cubed. Because 15 divided by 5 is 3. So if it's something that root will go into, it's fairly easy to do. If it's not, then we need to do some rewriting like we did with the square roots. So when I have cube root of x to the 8th, 3 won't go into 8 evenly. But what I can do is I can rewrite that x to the 8th as a power that 3 will go into, and I want to choose the biggest one, up to 8, the biggest number up to 8 that 3 would go into, and that would be an x to the 6th. So if I rewrote it as x to the 6th, the thing that would be left over would be an x squared. And then cube root of x to the 6th I can do by division. 3 goes into 6 2 times, and so I get x squared, cube root of x squared. Now when you're writing these problems out, it's very important to keep that little 3 on the radical. That indicates that it's a third root, as opposed to if you took it off, that would indicate it would be a square root. As another example, consider 4th root of x to the 13th. Again, 4 does not go into 13, but I can rewrite it as something that 4 will go into, which would be x to the 12th, and an x left over. And then I can divide 4 into 12 3 times, and then the other part's left over, 4th root of x, or 4th root of x to the 1st. As one further example, consider 5th root of x to the 18th, y to the 12th. Okay. 5 won't go into either one of those. I'm going to work them separately. So for 18, 5 won't go into it, but I can rewrite it as x to the 15th times x cubed, and then do the 5th root of x to the 15th by division. And so I get x cubed 5th root of x cubed left over, because 3 is smaller than 5 there on the x cubed inside. I can't go any further. For y to the 12th, I can rewrite 12 y to the 12th as y to the 10th times y squared. So, and then I can do 5th root of y to the 10th. 5 goes into 10 2 times. That would be y squared 5th root of y squared. Okay? And then we put everything together. Everything on the outside goes together. Everything on the inside goes together. And again, you need to have the little 5 there to indicate that we're dealing with a 5th root. Okay, we'll look at a couple more examples in an upcoming video. Until then, I'll see you later.